Hello everyone. Today we are going to learn haloalkane and haloarenes, which is basically from organic chemistry topic and from standard 12. Now see the halogen derivative of alkane and arenes. That is organic chemistry topic. So organic chemistry basically deals with the study of carbon reactions and the reaction of heteroatoms like NPOs, that is nitrogen, oxygen, phosphorus and sulfur. Now organic chemistry basically deals with the reaction also. So there are four types of main reactions. First one addition reaction, next one elimination reaction, next one substitution reaction, and last one that is rearrangement reaction. For the this topic point of view, halogen derivative of alkane and arenes, basically we are interested in substitution reactions, and I'll just show the example of nucleophilic substitution reactions, that is nucleophilic substitution reaction, bimolecular nucleophilic substitution reaction. See the example. This is the methyl chloride. When nucleophile attacks from the backside, then the attach of nucleophile, see the stereochemistry changes. CH3 from left hand side comes to the right hand side, and see the living species, that is Cl, will be lived. Now see the ball and stick model of SN2 reaction. See the nucleophile attacks from the backside and the living species will be lived. Now see, this is the example of nucleophilic substitution reactions. Now see, this is the bonding between haloarenes. See the bonding. This is the example of bonding in haloarenes. Now next, see today's positive thought or motivation thought, that is practice makes man perfect. Without practice you can't write down the reaction. So continuously practice is very important for the to write down the reactions or completion of reactions. Mistakes are proof that you are trying. So continuously if you are trying to write down the reactions, then you get the success. So the very important part, that is practice. If you do the practice, then you can write down the reactions easily. Now next, see the objectives of lessons. Now today we are going to look the introduction of haloalkane and haloarenes. In that point, we look the water haloalkanes, water haloarenes, and their uses, their applications, and how they are damaged to earth, and all the things we are look in the introduction topic. Next we look the classification of halogen derivatives, that is a monohalogen and polyhalogen derivatives. Next we look the classification of monohalogen derivative of compounds. And next last point of today's topic, that is nomenclature of haloalkane and haloarenes. Now see, in the introduction of haloalkane and haloarenes, we look the CFCs, that is chlorofluorocarbon, how damage or how destruct the ozone layer. We look the mechanism in this introduction, and also the haloalkanes are used as a solvent and used as a starting material in the chemical laboratory. Say the ozone layer, first of all, ozone layer is present in middle part of the atmosphere, that is present in stratosphere. So ozone layer is very important for all of us because it prevents the sunlight or UV rays. Okay, and see the mechanism. What happened when the chlorofluorocarbons, sources of chlorofluorocarbons already we know, it is used in the refrigerants, it is used in the industry also. So see, when the chlorofluorocarbon reacts with the sunlight or UV rays, what will happen? See, there is a free radical reaction and break this chlorine molecule. And further, when the free chlorine molecule reacts with the ozone molecule, in the ozone layer there is O3 molecules, that is no. When free chlorine molecule reacts with ozone Then there is a formation of chlorine monoxide and O2 oxygen molecule. Further, in the next step, there is a free oxygen molecule and chlorine monoxide reacts together, and there is a formation of another free chlorine molecule and O2 molecule. So this is the chain reaction, and the resultant free chlorine molecule in the stratosphere further continue the destruction or the depletion of ozone molecule, and this chain reaction is up continuously proceed in stratosphere. And that's why the ozone layer, there is a creation of holes between ozone layer, and that is very harmful effect on our atmosphere. And this is why, because there is a free radical mechanism works in presence of sunlight, and that's why the main reason of ozone destruction occurs in the atmosphere. This is very important part. Now see, introduction of haloalkane and haloarenes. And that, what are haloalkanes? Now see, when what are haloalkanes and haloarenes? When the hydrogen atom in aliphatic or aromatic hydrocarbons are replaced or substituted by halogen atom, then the corresponding compound is called as haloalkane and haloarenes. If the hydrogen atom is replaced or substituted in aliphatic compound, then that is the resultant species is called as haloalkane, and it is also called as alkyl halide. Now see the example of haloalkane, that is ethyl bromide. So in the ethyl bromide, see this particular halogen, that is bromine, is attached to the sp3 carbon. Okay, so this is the ethyl bromide. Next one, in the aromatic hydrocarbon, the halogen atom is attached to the sp2 carbon. This is very important. Now see here, the hydrogen atom is substituted in aromatic hydrocarbon by halogen atom, then the resultant compound is haloarene. That means the hydrogen atom of one of the aromatic hydrocarbon is replaced by halogen atom, then the corresponding species is called as haloarenes, and it is also called as aryl halides. In haloalkane, the Rx is the general representation, and in that X is represent the halogen group. X is equal to chlorine, bromine, iodine. Okay, so mostly we use the chlorine and bromine for the reaction purpose. Now see, it is attached to sp3 hybridized carbon atom. In haloalkanes, X group is attached to, that means halogen group attached to sp3 hybridized carbon atom in alkyl group, whereas in haloarenes, X group, that is halogen group, is attached to the sp2 carbon atom of aryl group. This is very important. See the example. Example of bromobenzene, that is C6H5Br, that is sp2 carbon, means bromine group is attached to the sp2 carbon. Now see, this is the sp2 carbon and this is halo group. So halogen group is attached to the sp2 carbon in aromatic system. Now next, introduction of haloalkane from general reaction. See, this is the RH group. This is the starting material. So in the reaction, we know the left hand side there is a starting material and right hand side is the product. So starting material is called as, already we know, that is the reactant. So now see, this is called as alkane. In alkane, one of the hydrogen atom is replaced by or substituted by X group, that is halogen group. Then there is a formation of the product, and that product is called as Rx, where R is equal to what? That is alkyl group, and the name of the product is alkyl halide. And C, the another name of product, that is haloalkane. So the common name is alkyl halide and the IUPAC name is haloalkane. Now see the introduction of haloarene from general reaction. Now see, RH, the reactant name is, that is already we know, arene. This is called as arene. One of the hydrogen atom is replaced or substituted of arene by X group, that is halogen atom, and there is a formation of Rx, where R is equal to AR means aryl group, where AR is equal to aryl group, and the name of this product is aryl halide is the common name, and the another name that is haloarene, that is the IUPAC name. Now see, multiple choice question, MCQ questions. Look the some question on this topic. Say, in alkyl halides, halogen atom is attached to, already we know, but see the options. sp3 hybridized carbon atom. Next one, sp3 hybridized carbon atom of an aryl group. sp2 hybridized carbon atom of an aryl group. None of this. Now this is the very simple answer, that is sp3 hybridized carbon atom of an alkyl group, that is option number 1. Next one, in aryl halides, halogen atom is attached to sp3 hybridized carbon atom of an aryl group, sp3 hybridized carbon atom of an alkyl group, sp2 hybridized carbon atom of an aryl group, and all of this. So already we know the answer, that is sp2 hybridized carbon atom of an aryl group. Next one, chlorofluorocarbon. Already we know the chlorofluorocarbons are used as a refrigerants. Let's see the options: fuel of crafts, solvents, and all of this. So basically, primarily it is used as a refrigerants. This is very important point. Now see the classification of halogen derivatives. Now see, the halogen derivative of hydrocarbons are classified mainly in two types. First one, the classification of hydrocarbon skeleton or their structure and hybridization. So they are classified haloalkanes, haloalkenes, haloalkynes, and haloarenes. See the example. This is the example of haloalkanes. In this haloalkanes, it is attached to the sp3 carbon. In haloalkenes, it is attached to the sp2 carbon. In haloalkynes, it is attached to the sp carbon. And in the haloarenes, it is attached to the sp2 carbon. Now next, on the basis of halogen atoms, number of halogen atoms, halogen derivatives are classified into monohalogen and polyhalogen compounds. See the example of monohalogen compounds, that is CH3CH2X, and this is the example of haloalkane, and this is the example of haloarenes. These are the one halogen atom, and this is also one halogen atom. So this is called as what? Example of monohalogen. यहाँ पे देखो एक ही halogen atom attached है, यहाँ पे भी देखो एक ही halogen atom attached है. So these are the example of monohalogen derivatives. And next, see the example of polyhalogen. Here, यहाँ पे देखो आप, यहाँ पे दो halogen group है, and see here there are two halogen groups. So these are the example of polyhalogen. When two or more halogen groups are attached to the particular systems, whether there is aromatic or alkyl system, then that is called as polyhalogen. Now see the classification of polyhalogen derivative of haloalkane and haloarenes. Now see, alkylene dihalides, that is dihalogen derivative. So it is classified into basically two types, that is geminal and vicinal alkyl halide. Geminal dihalide, that means when halogen atom is attached to the same carbon, that is called as geminal dihalide, and when halogen atom is attached to the adjacent carbon, then that is called as vicinal dihalide. We look in 11th standard also. Now see the example, geminal dihalides. See the two halogen atoms are bounded to the same carbon atom. Now see, this is chlorine and this is also chlorine attached to the same carbon atom. This is the example of geminal dihalide. And now see the example of vicinal dihalide. It is attached to the adjacent carbon. Now see, this Br attached to this carbon and this bromine is attached to another this carbon, and this is the 1,2-dichlorobenzene. See, this is also example of vicinal dihalide. Now see the trihalogen derivatives, that is CHCl3 chloroform. It is called as chloroform and trichloromethane. And now see the aromatic example, that is trichlorobenzene. Now see the tetrahalogen derivatives, that is CCl4 carbon tetrachloride, basically used as a solvent. And the aromatic example, that is 1, 2, 3, 5 tetrachlorobenzene. Not given the example here, but keep it in your mind. Now see the classification of monohalogen derivatives. Monohalogen derivatives are further classified on the basis of their hybridization point. See, the compounds with sp3 sp3 carbon with halogen bond. So here X is equal to fluorine, chlorine, bromine or iodine. Now see the example of further we look there are further divided into three types. Now see the alkyl halides. In case of in this class, the hydrogen atom is attached to an alkyl group. Now see the general formula of alkyl halide, that is CnH2n plus 1 X. This is the general formula of alkyl halide, and the alkyl halide shows by or represented by Rx. Already we know. And further it is divided into three parts. That is very simple. Already we learn that part in 11th standard also. That is primary alkyl halide, secondary alkyl halide, tertiary alkyl halide. This classification is based on carbon atom to which the halogen atom is attached. See the primary alkyl halide. This is the primary alkyl halide, RCH2X. This carbon is primary carbon because this is attached to another only one carbon. That's why this is primary carbon. Next one, secondary alkyl halide. This carbon is attached to another two carbons. See, this carbon is attached to this R group and this carbon is attached to this R group. So this is the secondary alkyl halide. And next one is the tertiary alkyl halide. Why this is tertiary alkyl halide? Because this carbon, ये जो कार्बन है ये अटैच है दूसरे तीन कार्बन को. See, ये कार्बन अटैच है ये R group को, ये कार्बन अटैच है this R group, and this carbon is attached to another this R group. So one carbon is attached to another three R groups. So that's why this is what tertiary alkyl halide. Classification of alkyl halides on the basis of carbon atom to which halogen atom is to attach. These are the example of primary alkyl halide, secondary alkyl halide and tertiary alkyl halide. Now see, monohaloalkanes contains one halogen atom and it is also called as alkyl halides. उसे हम alkyl halide भी कहते हैं. See, it is further divided into three types. We look in the chart format. See, this is the monohaloalkanes. Further divided into three types: primary alkyl halide, secondary alkyl halide, tertiary alkyl halide. Now see, what is primary alkyl halide? So basically, primary alkyl halide already we know, but we look, and in alkyl halide, when halogen atom is attached to primary carbon atom, that is called as primary alkyl halide. See the example, that is ethyl bromide. It is also called as bromoethane is the IUPAC name and ethyl bromide is the common name. Now see, this is the example of propyl chloride. Propyl chloride is the common name and the chloropropane is the IUPAC name. Next one, what is secondary alkyl halide? Now see, an alkyl halide in which halogen atom attached to the secondary carbon atom, then that is called as what? Secondary alkyl halide. So now see the example. This is the secondary alkyl halide. Why this is secondary alkyl halide? Because see here, this carbon atom is attached to another two carbon. Means this carbon atom attached to another this carbon and this carbon. So that's why this is the secondary alkyl halide. And guess the name. Is the name of this particular organic compound. This is the iso or secondary propyl chloride, or IUPAC name, that is 2-chloropropane. Next one, what is tertiary alkyl halide? See, when an alkyl halide in which halogen atom is attached to tertiary carbon atom, then that is called as what? Tertiary alkyl halide. Now see the example, that is one carbon atom is attached to another three carbon atoms. So this is the tertiary alkyl halide. The name of this alkyl halide is tertiary butyl chloride because there are four carbons are involved, and the IUPAC name, that is 2-methyl 2-chloropropane. We look the further rules also. In that rules we can see the how to do the name. Now see, can you write the general formula or general representation of alkyl halide? Yes, we can write. Already we know the general formula, that is CnH2n plus 1 X, and the general representation, that is Rx of alkyl halide. Now see the multiple choice questions. 2-methyl 2-bromobutane is dash dash alkyl halide. So now see the option: primary alkyl halide, secondary alkyl halide, tertiary alkyl halide, quaternary alkyl halide. So now see 2-methyl 2-bromo-butane means there are 4 carbons and the 2 position there is bromine also and methyl group is also. So definitely it is tertiary alkyl halide. So this is the answer. Now see which of the following is secondary alkyl halide. So इसमें से कौन सा secondary alkyl halide है? Ethyl bromide, 2-bromopentane, tertiary butyl chloride, isobutyl bromide. So out of that, which is secondary alkyl halide? So option number B is the 2-bromopentane is the secondary alkyl halide. Now see the classification of monohalogen derivative. Remaining classification जो है वो हम अब देख रहे हैं. That is allylic halides. In this case also sp3 carbon with X bond. This classification of compounds is formed by bonding of halogen group having sp3 hybridized carbon atom present next to the carbon-carbon double bond. That means the halogen atom is attached to the carbon and that carbon is present next to the carbon-carbon double bond. See the example. This is the allylic group. This is allylic group. See CH2, CH, CH2. This is allylic group. And this allylic group attached to the X group means this carbon, this halogen atom attached to this carbon. That's why this is allylic halide. This is sp3 carbon. Okay, see here, this is sp3 carbon. Show here. Next one, this is also example of allylic halide. This is also example of allylic halide. Example of halogen atom attached to the allylic carbon. Now see classification of monohalogen derivative. Benzylic halides. Now this is the sp3 carbon with X bond. Means benzylic system. That means this is the aromatic system. Now here the halogen atom attached to the sp3 hybridized carbon atom, which should be present next to the aromatic ring or benzene ring. For example, C. It is also classified into 3 types. C. Primary alkyl halide. See, this is the aromatic ring. And this CH2 group is present next to the benzene ring. So, this is the primary alkyl halide because this carbon is attached to another only one carbon. ये जो कार्बन है ये दूसरे एक कार्बन को अटैच है. That's why this is the primary carbon. And this is the example of primary alkyl halide. Now say the secondary alkyl halide. Here, this carbon atom is exactly present next to the aryl system or benzene system. So this example is belongs to or comes in benzylic halides. So now this carbon is attached to another 2 carbons, this carbon and this R group. So that's why this is the secondary alkyl halide. Now see next one is tertiary alkyl halide. Now this carbon is atom is attached to another 3 carbon. This carbon, this carbon, this carbon is attached to another this carbon. So this particular carbon means the halogen atom attached to that carbon and that carbon is attached to another 3 carbons. So that's why this is the tertiary alkyl halide. Now next one, classification of monohalogen derivatives. Now see the next type, that is compounds having sp2 carbon with halogen bond. Now these are the classified into 2 types, that is vinylic or vinyl halides and aryl halides. Vinyl halides means these compounds are formed when the halogen atom is attached to sp2 hybridized carbon atom. Okay, means halogen atom अगर sp2 hybridized carbon atom को attach रहेगा तो वो क्या रहेगा, vinylic halide. See, this is the sp2 carbon atom. This S group is attached to sp2 hybridized carbon atom. यहाँ पे देखो example में, ये example देखोगे आप तो समझ में आएगा कि alkene system है, this is CH2CH and the halogen group is attached to directly this carbon atom. Halogen group is attached to directly this carbon atom. So this is the vinylic system. This kind of system is called as vinylic system. This is also vinylic system. See, this is vinylic system. Okay. Example of vinylic halides. Now see the aryl halides. This class of compounds is formed when the halogen atom is attached to the sp2 hybridized carbon atom in aromatic system. Now see, already we looked the aryl halides. This carbon atom is sp2 hybridized carbon atom and this S group attached to this sp2 hybridized carbon atom. Now see, this is also example of aryl halides. This halogen atom is attached to sp2 carbon atom. These are the example of aryl halides or arylic halides. Now see the classification of monohalogen derivative shown by chart. See the chart. So we are going to simplify it. See the classification of haloalkanes based on the hybridization, sp3 hybridization and sp2 hybridization. See, sp3 hybridization, it is further classified primary alkyl halide, secondary alkyl halide, tertiary alkyl halide, allylic halide, benzylic halide. See the primary alkyl halide, X atom attached to the primary carbon. Secondary X atom, that is halogen atom attached to the secondary carbon. In tertiary alkyl halide, halogen atom attached to the tertiary carbon. In allylic halide, halogen atom is attached to the allylic carbon. Now see, this is the allylic system and halogen atom attached to the allylic carbon. Benzylic, halogen atom attached to the benzylic carbon. That means aromatic ring next to this carbon, that is CH2, and halogen atom attached to this CH2 carbon. So this is benzylic system. And sp2 hybridized carbon, already we looked in the previous slide, that is vinylic halide. See, this is the alkene and directly halogen atom attached to this carbon. So this is vinylic system. So this is the difference between allylic and vinylic. So this is very important. In allylic system, halogen atom attached to sp3 carbon, and the vinylic system, halogen atom attached to the sp2 carbon. This is a very important part. And next one part is arylic halide. Now see the arylic halide or aryl halides. Halogen atom attached to sp2 carbon, and in the benzylic, halogen atom attached to the sp3 carbon. So these are the very important points. So keep it in your mind. Next one, application of haloalkane and haloarenes. Already we know the haloalkanes are used as a solvents or used as a starting material in laboratories, and chlorofluorocarbon is also hazardous to us. Now see, haloalkanes and haloarenes are used as a starting material in the laboratories in wide range. Many industrial uses in day-to-day life also. In the pharmaceutical industries also used as a refrigerants, fire extinguisher also. Now see the main uses. They are used as a solvent in non-polar compounds. The derivatives of these compounds are used for the medicinal purpose, that is chloramphenicol, used for the treatment of typhoid fever. Very important, chloramphenicol used as a typhoid fever. Very important use. Next one, synthetic halogen compound such as chloroquine. Nowadays also chloroquine is used for the treatment of corona. See the chloroquine are used for the treatment of suffering from malaria. And DDT, that is utilized as an insecticide. DDT means dichloro, diphenyl, trichloroethane. So that is used as an insecticides, but nowadays it is not used. Now see the environmental effect. Already we know the CFCs, that is chlorofluorocarbon, how affect on our day-to-day life, how affect in the atmosphere. So see, there is a CFCs very popular or very important, that is example of chlorofluorocarbon, and very significant important, that is ozone depletion. It does the ozone depletion in the atmosphere, and that is very hazardous to us, very harmful to us. It damages the or it destructs the ozone layer, and this is the very important environmental effect. Next one, methyl bromide is also hazardous to us, and these compounds have been time again proved that the major problem to the environment because of their harmful effect. So be aware. Now these are compound. So methyl iodide does not cause any ozone depleting effect in the environment. Okay, so this is also important point. Now see the nomenclature of haloalkane and haloarenes. Now see the important point in the nomenclature. This is our last point. See the important point. Generally, there are two names are present for any compound or any compound. See, there are common system and there are IUPAC system. The common system, this is the separate from travel name because the nomenclature of common name is also required some set of rules. Now see the IUPAC name. Basic rules of the IUPAC already we learned in the 11th standard, but this is the next point of our first point of organic chemistry in 12th standard. So we look some basic rules for the revision purpose. Now see the basic rule. Find the parent chain in the compound, that is a longest chain. Find the longest chain in the compound. This is the very important rule. Next one, that is the find out the functional group and it will form the suffix. Functional group हमें find out करना है और वो हमें suffix में लिखना है. This is very important. And find out the substituents and their positions. जो भी substituent वहाँ पे है वो आपको find out करने हैं, observe करने हैं, and then it will write down in the form of prefix. Now see there is a priority order, very important priority order. Already we'll look in 11th standard, but see here there is an acidic group is present in first, then there is a sulfonic group, esteric group, acyl group, amide group, cyanide group, NC isocyanide group, aldehydic group, carbonyl group, hydroxyl group, SH group, NH2 group, OR group, COC, that is etheric group. Next one, alkene, alkyne, NO2, X and R. So this is very important sequence. So next point, nomenclature of haloalkane and haloarenes. See the rules in haloalkane and haloarenes. First, find out the longest chain. So this is very important. Already we know. Then the carbon should be numbered in such a way that the containing halogens or X group having least possible number. Further, if अगर वहां पे डबल बॉन्ड और ट्रिपल बॉन्ड है तो उनको पहले नंबर देना है, because we look in the priority order. Alkene comes first and after that there is a halogen group. So that is very important. Now see the example. In this example, see CH2 double bond CH, CH2 Br. So this is alkene system. So according to the priority order, alkene comes first, then the halogen group, and that's why the numbering should from this hand side. Numbering should from this hand side. So this is carbon number 1, 2, 3. So this is 3 bromo prop in or prop 1 in. So this is very important point. So that's why we look the rules and priority order. Now, if the multiple halogen atoms are present in the compound, they are named as a prefix di, tri, tetra, etc. The total number of some halogen atoms attached to the carbon atom. If more than one halogen atom are attached, then we can say that di, tri or tetra. See the example, that is CH3, CH, Cl, Cl. Already we look this example. This is the geminal halide, means one carbon atom attached to two halogen atoms attached to the one carbon atom. So this is the 1,1 dichloroethane. Why this is 1,1 dichloroethane? Because the R group, means halogen group, is gives first priority, and then there is R group. See, if you look at this is R group. R group is a last one, and first there is S group and then there is a R group. So that's why, see here, so that's why the first we give the priority to halogen group, and this is carbon number 1 and this is carbon number 2. So this is what 1,1 dichloroethane. Okay, now next, if the different halogen atoms are attached to the same compound, then they are named according to the alphabets. So that is also important. If there is bromine, then first take the bromine. Bromine and chlorine in present in one example, then we take the bromine because of alphabetically order. And the position of halogen atom in the compound is labeled by writing their respective positions. Means जो भी position होगी halogen atom की, वो हमें respective position लिखनी है वहाँ पे, and then the halogen group member just before the name of the parent name. That means we will look in the previous slide. Means first of all write down the halo, whether that is bromo. If there is bromo, then write down the bromo, and particular name write down the alkane, whether that alkane is ethane, propane. Okay, now see the example in the next one. Nomenclature of haloalkanes. See, the common name of haloalkane is alkyl halide, already we know, and the IUPAC name, that is very important, haloalkane. So is written in the format of the numerical position, alphabetically placed, halo, root, word, and last one, that is N. This is very important part. So IUPAC nomenclature. So how to write the haloalkane? So this is the rule: halo, root, word, N. This is the very important. Now see the some example. Now this is the 1, 2, 3, 4 carbon. This is the tertiary butyl chloride, is the common name. Already we will look in the previous slide. So this is the tertiary butyl chloride, the common name, and the IUPAC name. See, this is the R group. So first give the priority. Select the longest chain. Longest chain पहले select करनी है. This is our rule, basic rule. So first of all select the longest chain. This is our longest chain. Okay, this is our longest chain which contain 3 carbons. So this is the propane. It write down in the suffix. Now see, at the 2 number carbon there is a chlorine and methyl group. So this is what 2-chloro-2-methyl propane. Next one, see the longest chain. This is our longest chain. But the numbering from which side? This is the very important. So the numbering given from this side. Why? Because we are going to find out the list number, means halogen group कहाँ से attach है, कहाँ से पास में पड़ेगा, कहाँ से near जाएगा, means which is nearer to the, okay, nearer to that system. So halogen group is attached to this first carbon. So numbering should given from this side: 1 number, 2 number, 3 number, and this is 4 number carbon. So the name of this particular IUPAC system is 3-bromo. So why we take 3-bromo? Because in our rule we learn that the ascending order according to the alphabetically. So this is our rule also. So that is important. So that's why we write down 3-bromo, 1-chloro-butane, because of 4 carbons are there. So the name of this system is 3-bromo, 1-chloro-butane. Now see the next example. That is, there are also 4 carbons, and there is a problem because here also chlorine and here also fluorine. So from the which side we are going to numbering, that is important point. Now see, the more halogens are present in this side. So we are starting from here. This is carbon number 1, carbon number 2, carbon number 3, and this is carbon number 4. So according to the alphabetically, we are going to write down. So 2 bromo, 1 chloro, 4 fluoro, methyl butane, 3 methyl butane, because this is carbon number 3 and which contain methyl group also. So the name of this compound is 2 bromo, 1 chloro, 4 fluoro, 3 methyl butane. And now this is cyclic system. Okay, alicyclic system. Now see, in this system there is chlorine also, bromine also, iodine also. Now same problem, starting from where? Now see, the starting from this side. This is 1, this is carbon number 2, this is carbon number 3. So we are going to like this. So this is 2 bromo, 1 chloro, 3 iodo, cyclopentane. So there are 4 carbons in cyclic, 5 carbons in cyclic system, 1 2 3 4 5. So that's why this is 2 bromo, 1 chloro, 3 iodo, cyclopentane. Now next one, nomenclature of haloarenes. See, the common name of haloarenes are aryl halide, and the IUPAC name, that is haloarenes. Okay, now see, if there is a common system, then there is a ortho, para and meta positions are belongs. Now see, if more than one halogen atoms are present, the aromatic ring, then the number and the halogen group is named on the basis of the numerical position in the aromatic ring. That means 1 2, 1 3, 1 4, 1 2 3, 5, or 1 2 3. So according to this, we are going to numbering and always give the lowest number. The halogen atom is always given to the lowest number. So that is very important. And if there is a common system, then we write down the ortho, meta, para, these positions. Now see, this is the chlorobenzene. This is the chlorobenzene. We looked at some example. In that example, first one, that is chlorobenzene. Say this is the chlorobenzene, this is the bromobenzene. Now here, this is 1,2-dichlorobenzene. This is 2-chloro-toluene. Toluene, why? Because this is the toluene. So that's why numbering from here, this is 2-chloro-toluene. Now this is benzyl chloride, which is very important. This halogen atom attached to sp3 carbon and this halogen atom attached to sp2 carbon. You can compare between these two. This is called as benzyl chloride and this is called as what? Chlorobenzene. So don't confuse it. Most of the students are confused here. So benzyl chloride is what? This is the benzyl chloride, which is which system? Allylic system. And this is the arylic. This is arylic system and this is benzylic system. Okay. Now see, this is benzyl bromide, this is benzyl bromide, this is benzo tribromide. So these are the example of haloarenes. Now see the nomenclature of some compounds. We looked at some example. Now see, here one carbon atom is attached to another 1, 2, 3, 4 carbons. But we are going to deal with halogen. So think about only halogens. Halogen atom is attached to this carbon. So think about this carbon. This carbon is attached to another only one carbon. ये जो कार्बन है ये दूसरे एक ही कार्बन को अटैच है. Okay, so think about this carbon because we are going to learn the halogen derivative of alkane and arenes. So we think about the halogen group. So this halogen group is attached to only this carbon and this carbon is attached to only one carbon. So this is sp3 iodized carbon. And see the nomenclature, guess, this is the neopentyl bromide. This is the neo system. Common name system is neopentyl bromide and the IUPAC name starting from this side because this is R group and the priority first is halo and then R group. So starting from the 1 bromo, See the longest chain. This is the longest chain. Okay. Or see, this is the longest chain. Okay. This is the longest chain. 1, 2, 3 carbons are there. Okay. And 2 position contains what? 2 methyl groups. So this is what? 1 bromo, 2 dimethyl propane. This is what? 1 bromo, 2 dimethyl propane. Next one, that is which system? Already we'll look. This is allylic system. So this is allyl bromide. So the common name is allyl bromide, and the IUPAC name, that is starting from here 1, 2, 3. So this is 3 bromo prop 1N. Thank you.